My name is Radiez Delviller. I am a graduate student at ECU, and I'm also a research technician here at the Coastal Studies Institute. My master's project revolves around comparing the different soundscapes of oyster farms and their adjacent control sites. A soundscape is the amount of ambient noise within an area. Noise can be produced by boats, the gear itself, and mostly other fishes. Some of these fish will make calls for purposes of spawning, and others will do them inadvertently through feeding and just searching for food. You hear a lot of drumming, a lot of knocking, clicking, scraping, something like that. Spot and croaker make a very similar kind of drumming noise, kind of repeated drumming. And oyster toadfish make a unique kind of boat whistle-like call. By listening to the soundscape, we can see how these fish utilize these oyster farms, either by listening out for calls that are associated with different behaviors, such as spawning, and compare that to other areas that might be quieter. We choose a control site that's a distance away from the lease with no structure, no seagrass, just sandy bottom, whatever bottom that's the same as the oyster farm itself. A control site is just a way that we can have a site to compare to the oyster farm itself, to see if there's any differences within the soundscape. Currently we're sampling oyster farms in Buxton, Hatteras, and Herring Shoals.
I'm James Clower, and this is my partner Aaron Hopkins. We have Herring Shoal Shellfish Co. here in Flossie Creek, right off Herring Shoal on the Outer Banks of Oregon Inlet. With Ray's study, it's pretty cool because what that shows us is the amount of resident fish that come and congregate around our whole entire oyster lease and showing us how healthy the estuary is.
Since passive acoustic monitoring is such a non-invasive way of sampling, we can easily sample the biodiversity of these sites without having to actually see the fish themselves. At each lease, we deploy a hydrophone, which is an underwater sound recorder, and also a Smurf, which is a larval fish collector. Each hydrophone records for 10 minutes every hour, and they're left out for about 2 weeks at a time until we come back to retrieve them. Once the data has been pulled off the hydrophone, we use a software called Raven. We can listen to each file and kind of differentiate what fish are making calls. The Smurfs are deployed in a similar area to the hydrophone, and their whole purpose is to collect larval fish. That tells us whether the larval fish are attracted to the sound that the oyster lease makes. If there's more larval fish in the Smurf within the lease than in the control, if we can say that larval fish are attracted to the soundscape that the oyster lease creates. Projects like this are important because they show the interactions between mariculture and ecology in a way that not only because the oyster lease itself is beneficial through bearing oysters, but also the ecological benefits of it being a habitat for a multitude of different animals.